Just 15 kilometres from Oxford, an important experiment is preparing for a big day. Its purpose is to reproduce on Earth a process which produces energy inside the Sun. Pulses of energy are being created inside this machine in a gas of particles at over 200 million degrees centigrade. The process is nuclear fusion, the very same process by which the Sun gains its enormous energy. This venture is special. Scientists and engineers from all over Europe and indeed the world have come together to push forward our ability to harness fusion energy. The experiment is called JET and is leading the world in its achievement of bursts of fusion energy. The JET experiment is highly sophisticated and an adventure as exciting and focused as a space mission. What lies behind the project is use of the latest technology to take advantage of a very common fuel source: water. It's the elements within water that provide the key to the fuel for a fusion reactor, in particular deuterium, which is heavy hydrogen. A special facility has been built at JET to purify and recycle the fuel. It ensures that one of the hydrogen isotopes used in fusion, called tritium, is both recycled and kept isolated, because it's radioactive. What makes fusion so attractive is not only the abundance of the fuel source and the tiny amounts of fuel needed, but also the intrinsic safety and cleanness of the process. Disasters such as at Chernobyl could never happen, as there is no chain reaction in fusion. When these atomic particles, or ions as they are called, speed around, sometimes they collide. When this happens in the right way, a nuclear fusion reaction can take place, releasing lots of energy. The aim is to produce enough of this energy for eventual production of electricity for the grid. The challenge for the scientists is to try to control the frenetic gas of particles to keep the fusion fire going. This isn't easy. A bit like an unruly crowd, particles sometimes rush off in odd directions. The plasma is shaped by powerful magnets, but also many other frontier technologies are needed. One of the new technologies is the remote handling system for when the torus becomes radioactive. A special robotic system was devised to work inside the torus when it is radioactive. The robot, which is controlled partly by computer and partly by humans, installs new tiles inside the torus. These tiles help guide the plasma so that exhaust particles can be removed. The tiles are made of heat-resistant carbon and must be sculpted to present smooth surfaces and avoid hot spots. The whole experiment was designed first in virtual reality to prove its operation. The whole European fusion programme aims eventually at building a fusion power station. There are real advantages to be had. In a power station, just 1 gram of deuterium and tritium as fuel would replace 10 million grams of coal or oil. Also, the daily waste from such a 1,000-megawatt plant would be just 2 kilograms of helium for a fusion plant, compared to some 30 million kilograms of carbon dioxide and other wastes from a fossil fuel plant. By autumn 1997, JET's big day had arrived. On the 22nd of September, at about 9:30 in the evening, the JET torus operated for the first time with the full power fuel mixture of a future power station. 6 times more fusion power was made than the first ever production of controlled fusion in 1991, and 3 world records were set that night. Since the early 1960s, the Culham site in Oxfordshire has been at the centre of the world stage for fusion research. What JET has ensured is the continuing presence of a top-flight European project at the forefront of science and engineering.